Hello. In the previous video, we just considered the basic syntax for the list comprehension with just a single for loop inside the list definition. In this video, we'll talk about adding nested loops and if statements for implementing a somewhat more advanced example of Monte Carlo simulation in order to estimate the area of the geometric shape. So specifically, considering the following example, we want to count the number of integer points inside a circle of radius 20. And here's the visualization showing all those points in blue. In order to do so, we need to first recall the inequality describing all such points x, y within the circle of radius r. X squared plus y squared smaller or equals r squared. And now we can use it in order to find all such points. First, let's do it using traditional syntax. So first of all, let me specify the radius. And now start from creating an empty list of points. And for x ranging between minus r to plus r, and by the way, notice that if x or y are beyond r or minus r, their square is beyond r squared, so they can't satisfy this condition. So now for each x, implement a nested loop for y's, also ranging between minus r and r. Implement a condition check if x squared plus y squared is actually smaller or equal than r squared. And if that's the case, append the list with a tuple xy. And if I want to see those points, I can just print the list. Let us just peek into it, checking that the points make sense, and delete it. And here is the number of such points that we wanted to find. Let's actually get to the point of the video, doing the same thing in just one single line of code using a list comprehension syntax. So what I want is to find the length of the list, which consists of tuples xy for x ranging between minus r and r, for y ranging within the same range, and now for each tuple xy like that, we only include it in the list if it satisfies the following condition. So we put the condition after the for loop. This statement, one single line of code, if executed, will give us exactly the same result. So we've got the answer. Does this number actually tell us anything? Can we interpret it in some way? Can we check if the number is correct? Notice that the number of integer points inside a shape can serve as a Monte Carlo approximation of the shape's area, since each of such points basically represents the unit area, with a small exception of the points that lay on the border of the circle. In this case, this unit area is not completely located inside the shape. Apart from that, the number of points approximates the number of unit areas inside the shape, and this way approximates the shape area. But now we can estimate the shape area directly using a well-known formula for the circle area, PR squared. In order to do so, I first need to import the model math, which will provide me with the number p, and multiply p from math by r squared. This gives me the true area of the circle. So with 1257 points, we actually got as close as we could to this true value with an integer approximation. So this shows implementation of Monte Carlo simulation example with just a single line of code, thanks to list comprehension. So we just considered the way of constructing complex lists with just a single line of code, embedding simple loops, nested loops, and if statement within a list definition. And we just saw it working for a somewhat advanced Monte Carlo simulation applied case. List comprehensions are broadly used in Python and are often seen as one of the most distinctive features of Python syntax, making it so concise and efficient. Hope you will enjoy list comprehensions in your Python applications. Stay tuned for more Python features to discuss.